If you've ever wanted to figure out what your chances are of winning one of those games where you spin a wheel and it lands on a spot on the wheel, well, then this clip is for you because I'm going to show you how you would do that by determining theoretical probability. So I'll show you an example on the left, and then near the end of the clip, I'll get you to try your own problem involving a spinning wheel on the right. So let's go ahead and get started by looking at the first example problem. A spinner, that's the spinning wheel, is divided into 8 equal sectors, numbered 1 through 8. What is the probability of spinning an odd number? That's A. Then in B, what is the probability of spinning a number divisible by 4? Then in C, what is the probability of spinning a number less than 3? And let me just show you a picture of the spinning wheel. There you go. So it's got spots labeled 1 through 8, kind of like one of those game show wheels. All right, so let's get started with A. Determining theoretical probability is all about building fractions. That's what we're going to do in A, B, and C. And the fractions follow a rule that looks like this. We have the number of events watched divided by the number of possible events. And that's theoretical probability. So the number of events we're looking for divided by the number of possible events that can happen. So let me show you how we use that. For A, it's asking the probability of spinning an odd number. So the events that we're watching for in this case are the odd numbers on the wheel. So how many odd numbers are there? There's a 1, 7, that's odd, 5 is odd, and 3 is odd. So 1, 2, 3, 4 odd numbers. So 4 is the events watched. And the possible events, well, that's every spot on the wheel. There's 8 possible ways to stop on this wheel. So 4 divided by 8. Or in other words, probability of landing on an odd number is equal to 4 over 8. Or how can we reduce 4 over 8? Yeah, that's 1/2. So there's a tip too. Remember when you're doing probability questions to reduce your fractions. Okay, let's try B. For B, we'll apply the same formula that we see up there in A, but it's asking for the probability of spinning a number divisible by 4. Well, the events watched are numbers divisible by 4. How many numbers on this wheel are divisible by 4? Well, just 2 of them. 8, you can divide 8 by 4, and you could divide 4 by 4. So the number of events watched is 2. And again, there's 8 spots on the wheel. That's the total events. So the probability divisible by 4 is equal to 2 over 8. I can reduce that to 1 over 4. So somebody spinning this wheel has a 1 out of 4 chance of landing on a number divisible by 4. Or in decimal, 1 over 4 is 0.25, 25% chance of landing on a number divisible by 4. All right, let's tackle C. What is the probability of spinning a number less than 3? Well, how many numbers are less than 3? 1 and 2, just 2 numbers. 2 over 8, and that's going to reduce to 1 over 4, isn't it? Same answer. So probability, I'll say less than, I'll use that symbol for less than, 1 over 4. There you go. There's 3 examples of how we would determine the theoretical probability for a spinning wheel. Let's get you to try a practice problem now. For your problem, you can use the same wheel that I have here, and I'll show you what you're being asked to solve. A spinner is divided into 8 equal sectors, numbered 1 through 8. A, what is the probability of spinning a 2? B, what is the probability of spinning a number from 1 to 4? And C, what is the probability of spinning a number divisible by 2? Okay, so try A, B, C on your own, and I'll post a solution when you're ready. Let's look at your answers. For A, the probability of landing on a 2 is 1 over 8. For B, the probability of getting a number from 1 to 4 is 1/2. And that's because 1 to 4, if you look at it, it takes up half of the wheel. Then in C, the probability of landing on a number divisible by 2 is 4 over 8, and we reduce that to 1/2.